If f of x is maximum of sin x and sine inverse of sin x, then we need to evaluate integral 0 to 2n pi f of x dx. So as the function f of x is given as a maximum of a combination of two functions, first let us split the function f of x and write it as a piecewise defined function. What is f of x defined? F of x is defined to be the maximum of sin x and sine inverse of sin x, right? Now, using the graph of sin x and sine inverse of sin x, we can see that f of x is x if x lies between 0 and pi by 2, and it is minus pi minus x if x lies between pi by 2 and pi, whereas it is sin x if x lies between pi and 2 pi. Now, as the required integral is from 0 to 2n pi, the required integral I is from 0 to 2n pi of f of x dx, right? So, can we rewrite this as the function is periodic with period 2 pi, this can be written as n times integral 0 to 2 pi f of x dx. Now, n is a constant outside, but by definition of f of x, this has been defined into three piecewise definitions between 0 to 2 pi. So let us write it as integral 0 to pi by 2. Between 0 to pi by 2, how is the function? Yes, it is simply x dx plus the next interval is from pi by 2 to pi. The function defined is minus pi minus x dx plus the last interval is from pi to 2 pi and the function happens to be sin x dx. Now we have three different parts of integrals. So let's evaluate the integral separately. This is n times x square by 2 evaluated between 0 to pi by 2 plus minus pi x minus x square by 2 evaluated between pi by 2 to pi plus integral of sin x, that is minus cos x between pi and 2 pi. Now you know how to evaluate this upper limit minus lower limit. This comes to n times pi square minus 8 by 4. Let's see which option does it satisfies. N times pi square minus 8 by 4, which is option presented D. So the problem became so easy once we defined the function f of x as a piecewise defined function between 0 to 2 pi, and because of the periodicity the n comes outside, then we can integrate it only between 0 to 2 pi and the whole integral is now multiplied with n, right?